Okay, welcome everyone. This is our video on doing logistic regression in Excel. And so I'm going to do this. I think we have time to do a couple of examples because it's actually relatively quick. Now, what I have here is I have this data, which only has two X variables, X1, X2, which is income and lot size, and it has our Y variable ownership. The first thing we need to do is just convert the ownership into zeros and ones. Right, so if this says owner, then we're going to give it a 1. Otherwise, we're going to give it a 0. And just bring that down. Now we have our Y values. This is all good. We don't need the Y values to be next to the X values. Not necessary. So then what we're going to do is over here, we're going to set up B0, B1, and B2. And that's all we need, just B1 and B2, because we just have X1 and X2. And I can leave those blank. We're going to use solver to tell us what those should be. Or I can put in some numbers here. I can put in like a 1, 2, and a 3 if I just want to start seeing things in my formulas. If I leave them blank, then everything's going to look like zeros, which is okay, but it's sometimes hard to tell what's going on. So now over here, I'm going to write a column for the logit, a column for the odds, and a column for the probability. All right, and this is the probability that y equals 1. If I want the probability that y equals 0, I can get that as well. Well, I'm just going to cut and paste this a little bit further over because I'd like some more room. Right? I don't technically need both these columns. I can do everything with just one of those columns, but it's nice to have here. And then I could have a column that does my classification. I could also have a column that does my likelihood, which we're going to talk about in a minute. And then I would have the log likelihood. Okay. So first of all, the logit. The logit is just the linear regression part. It's going to be the constant, which I make static, plus the sum product of these coefficients, which I'm going to make static, with the x values, which I'm not going to make static. Right? So this is just like the linear regression part. It's 1 plus 2 times x1 plus 3 times x2, or whatever. Right? And by having 1, 2, 3 here, I'm actually going to see different numbers here, which is nice. If I leave these blank, then I just see zeros here, and it's harder to tell what's going on. The odds, I'm going to do e to the power of the logit. Now, I have a problem because these logits are now too large. That's not good, right? I get errors. But if I set these back to zeros, then, oh, sorry, that wasn't the reason I got an error. I used the wrong formula, exp of this, right? You can't do e to the power of that way in Excel. You have to do it this way. This is my my e to the power of the logit. Okay, and so this is huge, right? It's not huge enough to get me an error, but it's huge, really, really big. If I go much bigger, I will start getting errors, right? If I had like a 7 here, I don't know how big I have to go to get errors. Yeah, there I go. Okay, now I'm starting to get errors. All right, so if these are too big, you start to get errors. So anyway, this is all right for now. What we want now is the probability, right? So the way we get the probability should be the probability that y equals 1 should be the odds divided by brackets 1 plus the odds. And this is going to look like a 1 because these are all huge, right? So now my idea of, oh, if I put some numbers in here, I'm going to see different stuff here. It's not really working out because these are all so big. But if I put in some negative stuff here, well, now they're all so tiny, but they're different tiny numbers at least. Anyway, it's okay. These are going to get fixed later. The probability that y equals 0 is just going to be 1 minus the probability that y equals 1. Okay. So remember the formulas were, the logit was the linear regression part. The odds were the exponent of the logit, so e to the power of the logit. The probability was the odds over 1 plus the odds. And this probability that y equals 0 is 1 minus that probability. Right? Specifically, these are the odds that y equals 1. So if we want to make a classification, this is pretty easy, right? It's just if this probability is bigger than that probability, right? If the probability that y equals 1 is larger than the probability that y equals 0, then we're going to classify it as a 1. Otherwise, we're going to classify it as a 0. Right? So right now, everything is getting classified as a 0. Everything seems to be more likely to be a 0 than a 1. But that's because these aren't correct yet. That's okay. We're going to fix that. So now what we want is the likelihood. Now the likelihood, these are the probabilities, but we have to pick the correct probability. So what's happening is when y equals 1, I want to pick the probability that y equals 1. And when y equals 0, I want to pick the probability that y equals 0. This column, right? So I want to grab either this column or that column. Which column I grab depends on what y was. Right? So this is if y equals 1, then I want to pick this column, otherwise that column. Okay, so we'll bring that down. And this is fine. I have all my likelihoods. The goal is to make these all large, right? Because when y is a 1, I want the probability that y equals 1, according to my model, to be very high. And when y is 0, I want the probability that y equals 0, according to my model, to be very high, right? I want to make these as large as I can. But what I'm maximizing is not exactly the likelihoods, it's actually the log of the likelihoods. So the log likelihood is just the log of the likelihood. Bring those all down, and you can see when the likelihoods are larger, the log of the likelihoods are larger. They're all negative, but these get closer to 0. Right? You can see the smaller these likelihoods were, the farther from 0, the more negative these log likelihoods were. So then, if we sum those up, sum the log likelihoods, I want to maximize this number. Okay, that's my goal. So I'm going to go into solver. I'm going to tell solver the set objective. The objective is this cell. That's my objective cell. I want to maximize it. And I want to do that by changing these variable cells here. There are no constraints, but I definitely want to uncheck that box. I don't want to make them non-negative because some of them are going to be negative, I think. I think some of them are going to be negative. Usually some of them are negative. And then I want to do non-linear. Right? If you do LP, that's for linear programming. We're going to see that when we do our linear programming class at the end of the term. This non-linear is what we want. So I'm going to have that selected. I'm going to click solve. And it counted an error in the objective cell. Right. So if you get errors here, then you get errors here, right? Now, we're getting errors here because it's trying to take the log of a number that's too close to 0. So that's not good. Why are we taking numbers that are too close to 0? Oh, I see. We got, when these numbers get too big, it can break things here. Let's try starting from a different spot. Let's try starting from here. Changing the variable cells here, making sure I have the correct thing selected. M2, solve. Aha, see? So now it matters where you start. Because sometimes when you start from the wrong place, Excel's going to start trying numbers that give errors, and then it's going to stop. And it's going to be like, whoa, we have an error, right? So if we start from blanks, in this case, we get better results. We actually get a solution. This solution has given us our minimum sum of log likelihoods. And so we can see that for each of these different values, we have a probability that this person owns a lawnmower and a probability that they don't own a lawnmower. And then we've guessed whether they own a lawnmower or not. And we can see that there are some errors, right? Of all the people who own lawnmowers, of these 10 people who own lawnmowers, 8 of them were guessed correctly and 2 of them were not. Of the people who don't own lawnmowers, 8 of those were guessed correctly and 2 of those were not. All right, so we got about an 80% success rate on this data with this. Now, this is obviously the training set, so we might perform worse on a test set. We'll have to see, right? If we had a test set, we would plug in this model and find out, right? But we can see here our coefficients, and these coefficients mean something, right? So especially if I do e to the power of those coefficients, right? This is 1.117. So that's like 112%. Right? So if I do this minus 1 and think of that as a percentage, right? Let's make those both percentages. What does this mean, this 12%? This tells me that for B1 was income, right? This tells me for every, in thousands of dollars, for every additional $1,000 of income, your odds of owning a lawnmower go up by 12%. Now we're talking about the odds, not the probability here, right? It's not the probability goes up by 12%, it's the odds go up by 12%. So if the odds were 2 to 1, well, now they are 2.24 to 1 because they've gone up by 12%. This one says for lot size, which I don't remember what the units were, but for whatever units those were, for every additional unit, right? Maybe that's 1,000 square feet. I don't know. Maybe it's in meters. Maybe it's hectares. I'm not sure. Whatever it is, for every additional unit of lot size, your odds of owning a lawnmower go up by 162%. That's a 162% increase, right? So if your odds were 2 to 1, then now they're going to be like 5 point something to 1 because they've gone up by more than 100%. So lot size is having this big impact on each additional unit of lot size is having this big impact on how likely you are to own a lawnmower. Okay, so that's logistic regression. We can do another example when we're going to see it's all basically the same. Here, now with this one, like we saw in class, this education variable needs to be turned. We could turn that into dummy variables. I'm not gonna bother just because I'm really just trying to show the logistic regression part here, right? But if you want to do it properly, then you turn that into dummy variables first. If we're not turning it into dummy variables, then we're assuming something about this. What are we assuming? Right? This is ordinal. If we're not turning into dummy variables, then what we're doing is we're assuming that the difference between 1 and 2 is the same as the difference between 2 and 3. We're assuming this equidistance, right? So I think this was like, what was it like? No college versus college degree versus graduate degree, something like that. So we'd have to make this assumption that the difference between no college and college is the same as the difference between college and graduate, or something like that, which may not be a good assumption. All right, but rather than spend the time in this video doing dummy variables, which you know how to do, dummy variables, I'm just going to spend it actually doing the logistic regression. So the way the logistic regression works, remember, is we're going to need a logit, we're going to need odds, we're going to need the probability that y equals 1. We're going to have a probability that y equals 0. We're going to have classification. We're going to have a likelihood. We're going to have a log likelihood. And then we're going to have our sum of our log likelihoods eventually here. So over here, we need the B0. And then how many different X values do we have? We have 1. We have 11 X values if I leave education as it is. Right, we got 11 X values. So I'm going to need a B1, a B2, a B3, B4, B5, B6, B7, B8, B9, B10, and B11. Now, having all these different X values actually really doesn't make it harder. Right? We have 11 X values instead of 2. You're going to see it all ends up being the same. Right? So the logit is going to be the B0 plus the sum product of all these other B's, which I make static. The B0 is static. Please don't forget to make the B0 static. It's really easy to forget to make the B0 static. You'll immediately see a problem that you went wrong if you don't make the B1 through B11 static. It'll be obvious that something's not working, but it won't be obvious that the B0 is not working if you forget to make that static. So please remember that has to be static. And then all of these, which are not static. All right, this is my logit. My odds are going to be e to the power of the logit. My probability that y equals 1 is going to be odds divided by 1 plus the odds. Remember your brackets here. If you forget your brackets, it's going to be all wrong. Your probability that y equals 0 is going to be 1 minus the probability y equals 1. The classification, right? We can bring all these down. Classification is just going to be if this is bigger than that, then we're going to give it a 1, otherwise a 0. Right? If it's more likely to be a 1, we're giving it a 1. If it's more likely to be a 0, we're giving it a 0. The likelihood, right? Remember how this one works is if the y, right? This column was actually the y value. These are my y values. This is what I'm trying to predict here, right? So if this was actually a 0, then we want to give it the probability that y equals 0. Otherwise, if it was actually a 1, we want to give it the probability that y equals 1. The log likelihood is literally just the log of the likelihoods. And then the sum of the log likelihoods is the sum of all of these. And now it's all set up, right? So I went a little bit quickly, but that's because we already did this in the previous sheet, right? We're just showing the same thing twice, showing you how that having all these extra variables doesn't actually make it any harder at all. So we go to solver. The objective cell is here, the sum of the log likelihoods. The variable cells we're changing are B0 to B11 here, these ones. And we're maximizing the objective. We have to make sure we uncheck that box. If you check that box, it's going to all break. There are no constraints. We're doing nonlinear, and we solve. And the fact that there's so many variables makes this quite a bit slower, but it's still going to work. There's also a lot more data. Right? The other one we only had, I don't know, not much data, 20 people. This one we have a lot more. But anyway, we get our solution, right? So now we have all of these things, and we can interpret these as like percentage changes, right? We can do the exponent of this minus 1 and write that as a percentage. Right? So we can think of all of these as what percentage change in the odds does an increase in this variable give us, right? So increasing B1, which was age, decreases the likelihood, the odds that a person will get a loan, right? So if you, for each additional year of age, the odds of you accepting a personal loan decrease by about 5%. Okay, so that's it. That's how we do logistic regression. So on your assignment, you're gonna have a little bit more complicated. Excuse me. On your assignment, right, you're gonna have multiple values of y, not just two values, but three. You're gonna have 0, 1, 2, or 1, 2, 3, however you want to code it. And so you're going to need a whole other equation, right? You're going to need like C0, C1, C2, etc. And you're going to use the first equation to get a logit and an odds and a probability for y equals 1. You can use the second equation to get a logit and an odds and a probability for y equals 2. And then the probability that y equals 0 is just going to be 1 minus those. You're only going to have one likelihood value, right? That likelihood value looks at the actual y and uses the actual y to pick out the correct probability of the three probabilities you're going to have, because you're going to have three probabilities when you're doing this on your assignment. And then you're going to do the log likelihood, sum those up, and maximize that by changing both equations, this group and that group. Right? So your assignment's going to be the more complicated version of this. All right, so that's it. That's the video. I'll see you all in the next video.